So, good evening.
Welcome.
Welcome you guys. Thanks for joining us today. So, my name is Fran Gomez. This is Cesar Jimenez. We are
Hi.
working at Divo. And before we start the presentation, we would like to play with you and show you what want to do today with you and what I want to, which the this presentation is just about the facial recognition, so we can start making this. Okay.
Mhm.
So first we will show two videos. Okay. You can show the videos. Okay. This video is just a video from our company. It's a great.
Time.
It's a great company, and in this case, we are using a training set that contains a lot of images from Raúl and from Samuel, and we are detecting these guys in a very well way. Okay, so if we try to do this just using the face from the LinkedIn contact, okay, we are getting all our LinkedIn contacts. We can show that we can detect who of these guys of the company are in our contact list. So here you can see there are a lot of unknowns because the training set is too poor. We have only one image from
Its face.
its face. This is not a good training set, but you can see all my contacts, and you will see the contact that we are setting, Cesar and me.
Mhm.
Okay, so they are eating a lot. Okay, the idea is make this right now. Okay, do you wanna play? So this mobile phone is just streaming the video to the laptop, okay? The quality is not good, okay? And the idea is we are trying to know who of you are in my LinkedIn contacts. It's better than scan the budget, okay? So can I get your image?
We are not recording.
We are not
It's only
recording. Can I?
live and streaming.
I don't know if you are in my contacts.
And I?
No?
I am in your contacts?
Maybe. No?
No.
I need more.
Yes.
Yes? I have only one photo from LinkedIn, so the facial recognition is not so good.
Yeah, but
Okay, but
appear.
put here. Yeah. Okay. So any of you are in our contacts? No.
No.
This could be fail. Huh?
Well, we are talking about false positives and false negatives.
How many years has your photo? Okay, so this is just a demo to show what kind of things we are trying to do today, okay? So let's continue with the presentation. Our agenda today is just talking about open source intelligence, video analysis, of course, and the face recognition. And at the end, we will show an example of an use case to use this kind of technology, aptly to some of. We will see.
Yeah.
So let's start with the open source intelligence. How many of you know what is open source intelligence? More.
Yeah.
All of you know what is open source intelligence. For me, the best definition starts like this. Information does not have to be secret to be valuable.
Mhm.
Okay? Another definition could be this. Open source intelligence is data collect from publicly available sources to be used in an intelligent context. An intelligent context is the place is when you have all the information that you need to take a good decision.
Yeah.
Okay? So You can use open source intelligence to the national security, counter-terrorists. You can use to monitor competitors, to identity persons. Many applications, like even you can get the ROI from your advertisement in the social media.
Yes, in this case, don't identify faces, identify logos, brands, and these kind of things, and count the amount of time of your logo are in screens, in TV, in something like that.
So today we are trying to show you the capability of the video analysis. So this is because by 2021, 80% of the world's internet traffic will be video, okay? So this is a forecast, and for this year, the forecast is that 90 million of terabytes or more will be video on internet, and only 2% of this video is from surveillance cameras.
Yes, these data are from Cisco.
So video is an important source, and it's growing, because every day, much more video are allowed by users, because users don't want to text or write. Users want to listen and talk, okay?
We are lazy patrons.
Yes. So let's move to the next point, and I'd like to share with you an example of how video processing can help you to obtain more information, okay? We're sorry, but the video has sensitive content, okay?
Yeah, sorry.
The video is part of the ISIS propaganda campaign. I don't know if you know about the ISIS propaganda. I think so. So you can show in the video how some terrorists killed some hostages, and the idea is to know where and when the video was recorded. Okay? And to do that, the first question, where the video was recorded, you can use image from Google Maps and correlate with the building, roads, and buses in the video to get the location of the video. When you get the location of the video, you can know when the video was recorded. Okay? To get this information, you can use the blue spots in the ground.
Yes.
And thanks to the Google History database, you can compare and get when the video was recorded. So before the video analysis, you only know that some people were killed. And after the video processing, you know when and where these their people were killed, okay? So today, we're focused on facial recognition because it's one of the machine learning applications that has had more advantages in recent years. So before Cesar shows you how the facial recognition works in a hard way, I will try to share with you my 6 simple steps to understand the facial recognition. So the first step is you need to know where the face is. You can use Hawk or CNN algorithms, okay? And then you can obtain the landmarks, and you need to align the image to get the correct landmarks. So you can scale, rotate, or stretch the image, and when you have the face and the landmarks aligned, you can obtain the vector array that defines your face, okay? The vector array is just 128 values that define the face, and you can use this to compare with all other faces that you have in your database. So, Cesar, explain these guys the process in the hard way.
Okay. I hope this is not the hard way, but... Okay, in the first step, we try to identify where are the faces in the image or in the videos. We need the coordinates of the face that appears in this video or in this image. Well, this is not a simple task because, like you can see, Will Ferrell and Chad Smith are like twins.
But they are not family.
No, but identify person is not a simple task. If you think if identify objects is more easy, and I see you, it's easy to identify and find difference between muffins and chihuahuas? All the people say yes, but this is not an easy way. Okay? Like you can see in this image, which are chihuahuas and which are muffins. It's very complicated to say. Okay. The recognition of these faces, where are the faces in the image? In this talk, we talk about HOG, histogram of oriented gradients, and CNN, convolutional neural network. Well, start with the histogram of oriented gradients to locate face in image. Well, the HOG technique was developed in 2005 and try to find when the darkness points of the image move and draw oriented gradients towards these directions. You can obtain some image, like you can see, is a pattern of my face, of a pattern of a front face, and you can try to find this kind of patterns along the whole image in the video. Well, when you can see, this kind of pattern is very easy to use in image, but have a problem with the orientation of the object. This kind of patterns is invariant when the faces are in the left corner or in the right corner of the image, but this variant is the faces in the front or by side, or this kind of things. Well, for classify this kind of patterns in an image, in a video, and identify where are faces and what objects are not faces, we use a support vector machine algorithm. This is an old algorithm, and try to identify what objects are faces or not faces. This is based in create an optimal hyperplane that divides the plane in 2 dimensions. You divide the plane in 2 areas, and in one area are faces, and in the other area are not faces. Well, in n dimensions, like we use in the HOG algorithm, this hyperplane is a surface in n dimensions. Okay, the other techniques that we can use to identify where are the faces are the convolutional neural networks, and is widely used in, to address various problems in recent years, and have the advantage that is designed to require much lower processing than traditional deep neural networks. Deep networks are inspired in the connectivity patterns in the neurons of the cortex, of the visual cortex of animals. And the first step in the convolutional neural network is a convolutional operation. It's very easy. You start with a matrix of the image, with all the values of each point in the image, and apply a kernel. This is this kind of matrix, in this case 3 times 3 matrix, and make operation like you can see, plus and multiply the values, and obtain a final matrix with the representative objects.
Values.
Yes, values of the objects. Well, for example, if you try to detect vertical borders or vertical edge in an image, you can choose a matrix, like you can see, the kernel, and for this kind of image, black and white image, you can obtain the vertical border of the image in the center of the matrix, normalizing these values to 255 for a grayscale image. Okay, you can choose or you can use GIMP tool to make this kind of operations and play with it, because the GIMP tool have a convolutional matrix operation. In this case, with my photo, apply a kernel, like you can see in the previous image, with 1, 0, and -1 in each column, and obtain the vertical edge of an image. Well, the next operation in convolutional neural network is a subsampling. It's a reducing the amount of data. And one of the most used is max pooling. In this case, the max pooling operation is very easy to explain. You choose a matrix site, in this case 2 times 2, and divide the image in regions and choose for each region the eigenvalue of each section. 7, 9, 8, and 4 in the image, like you can see. Finally, with all these kind of operations, convolutional subsampling, you obtain a lot of matrix, and these matrix are flattening in a vector, and this vector is the feed for a traditional neural network. A traditional neural network with her inputs, her activation functions, her outputs, and the output is the location of the face. Caution. You can use CNN in CNN videos because the wall can implode by the recursion. Okay, when you use CNN or HOG? Well, CNN algorithm is more precise in object recognition, but in contrast, HOG is faster in processing. You can use for processing offline or video in real time.
Yes.
Well, these techniques of object recognition, face recognition in our case, can be used to identify a lot of objects, like buildings, cars, flags, like you can see in the image, or guns and roses, all the things. I love rock. Okay. The next step is find some specific points in the faces, called landmarks. These points identify some parts of the face, the nose, the chin, and why do we need these points? Because in the next step, we obtain a code for each face and need all the face aligned to the same position. We identify this object, and with operation like scaling, rotating, stretching, you can align all the face to the same position. In this case, like you can see, this affine transformation deform a little the image, but obtain a better results in the next step. The next step is face encoding. Face encoding is used to obtain a numerical code for a face, and this is an investigation in 2015 by Google, and use a normal neural network, and this network is training with triplets. These triplets are two faces belong to one person, and one face belong to the other person. This allows to minimize the distance between false positive, false negative, positives and negative results, and finally obtain a vector like you can see. These are the 128 dimensions or 128 measurements of each face, and this is like a vehicle plate of a person. In this case, these numbers don't correspond with any measurements of the face. It's not the distance between the eyes or the length of the nose. There are only the exit or the output of the neural network training with triplets. Well, after that, go to the last step, the facial recognition. And in this step, you can obtain true positive if you find in this example, Cesar is in the image and Cesar is detected. One false positive is Cesar is not in the image, but Cesar is detected. A false negative in the case that Cesar is in the image, but Cesar is not detected. And a true negative if Cesar is not in the image and Cesar is not detected. We try to maximize these two results because they are the good results. Well, for this, we use a tolerance, and we use the Euclidean distance between vectors, the 128 vectors in the previous steps, and use a tolerance, and if the Euclidean distance between these two vectors are in our tolerant range, the person is the same person.
Same person.
Yeah.
Or we know that the person is the person.
Yeah. You can move the tolerance to balance between true negative, false positive, true negatives. And like you can see, you can obtain a balance between false positive rate and sensitivity in a ROC curve, like you can see in other machine learning algorithms. Yeah. Well, all of these steps allow you to identify the person that's known and have in our models database to identify this person, but what happened with the persons that don't know? The unknowns.
I need this. Okay, it was the hard way, no? So,
Nah.
any of you know where this expression comes from? Unknown unknowns? Nobody? No problem. You know. Perfect. Let us show where this expression comes from. So, go, Mr. Ransfeld.
There are reports that there is no evidence of a direct link between Baghdad and some of these terrorist organizations.
There are known knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know.
Excuse me, but there are reports that there is...
So, unknown unknowns. Why? Why we are talking about unknown unknowns in facial recognition presentation? Okay, this is because our use case today is related to ISIS propaganda. Okay, ISIS propaganda on social network is trying to focus on spread their ideas on obviously fear. So social networks are trying to stop this kind of content, but they are failing. So we will try to use this content, okay, and the idea is just to identify who is who in this kind of videos. So the most of the person in the videos are unknown unknowns, anonymous people that we don't know, okay, and we need to classify as the first step to identify them.
Mm-hmm.
So time to see the video, and the video, no, the demo. Cross your finger. Says.
Yeah. This is the hard part.
Okay. Here we have, this is the topology, okay, that we are using. We will explain the topology and the architecture. So we need to start the topology right now because the process is so slow. So we start the process. This is a local storm cluster.
Yes.
I don't know if you are familiar with this kind of technology, but we will see the topology and the architecture, don't worry. And when this start, we need to put 2 videos or 1?
Like you prefer.
All in. All in. This and what is the... No. This one. Okay, so let the system works, and we will explain you the architecture and the technology that we are using here.
Yes. Let the system run and let the river run.
Let the river run. So we are using OpenCV, just obviously to process the video image, okay? So this library started by Intel a lot of years ago, and we are using Apache Storm as the real-time framework processing, and we are just using dlib because there are a lot of machine learning algorithms and a lot of tools to process the image, okay? Mm-hmm. And with some libraries from Python and Java, we are just compounding the system. So the topology is as simple as you can see here, okay? The topology is just getting videos from internet. In this case, we are just trying videos from YouTube. Mm-hmm. And the spot, the first part of the topology, is getting this video and split the video to sampling and sending these frames to the next step. The next step is just the identify faces. This step is just trying to get the faces that are in the image. Here we are using Hawk because this is a real-time system. We can use CNN. And then, in the next step, we are trying to recognize who is in this image, okay? So when we know that a people is in the image, we store in the known people database. Okay, the wanted people models are training with CNN. Okay, because we have it's an offline process and we can spend a lot of time to training the data set. Okay, and the last step and the more complicated is what can we do with all the people that we don't know, that people that we don't have in our model, in our training data set. The unknown people, we are just trying to put in the unknown people database, and we are trying to put in another database the relationship between these guys, okay, to know where a guy is, okay, and where other guys are in the same video. So the problem here is how can group the unknowns? Okay, so Cesar, please.
The other hard part.
The other hard part.
Okay. In this part, we try and we use three kinds of algorithms. The first of one is as a hash similarity or a percentual hash called p-hash. P-hash is very famous because it's useful in detecting brands and logos in fake webs in phishing cases, because find the similarity of two images and offer a number, or the output is a number, yes. And if this number is similar, the images are similar. In this case, don't work properly for us because the image for the background, the brightness, the face position offer different values and don't work properly.
No.
Well, the next step, yes. The next step is making a dataset with all the face that we can find in videos, a dataset with the 128 values or measurements of each face that appear in the video. With this dataset, we try to use k-means algorithms, and k-means algorithms work properly but have a problem. In this algorithm, you obtain a partition of the space, of the example space, and all the data is around a center point called centroid. And in this case, work properly if you know how many different peoples are in videos. In this case, it's difficult to obtain how many different persons are in the videos, and the estimation of this number with different algorithms don't work properly for us in our case. Well, but finally,
the
winner is the Chinese whisper algorithm. This algorithm is very useful and has a wide use in processing natural language, and is based on the creation of a graph with all the faces that we identify in the previous steps with 128 vector dimensions, and joining the nodes and follow these easy 3 steps like you can see. It's very easy to implement and very easy to use because it's a simple algorithm, but for us offer the best results. Yeah, the best result. This kind of aggregation allow us to respond to questions like in which video this person appears, or this person in what other videos appears. Finally, with this algorithm, we have different unknowns in groups, and these groups have the same person, but different person of other groups. Well, if you need to improve the results of the facial recognition, non in videos, in YouTube videos like we see, like surveillance cameras of this kind of technology, you can use a three-dimensional face recognition technology. This technology can obtain higher accuracy than their two-dimensions counterparts. Yes, for this you need a special camera, like the 3D camera in iPhones, in Face ID technology, is used this kind of camera, or Intel RealSense camera, and these cameras project a mesh of infrared points to the face, or use twin cameras to obtain an additional dimension that apport more data to our analysis. In this case, if you have more data in the most of the machine learning algorithm, you can obtain better results. In this case, the three-dimensional face recognition is based in this simple task: obtain more data for the same face.
So
it's time to
demo epic or fail. We don't know. Don't worry, we have a video. So the idea is that the topology is working. We're just identifying, extracting, and whispering. Okay. So here are the results. In the file system, we have the people that we know, these two guys, and the people that we don't know here, and the people that we don't know classified. Okay? So to show this, it's better to use a graph. Okay? So in this case, I don't remember who is who. This is the unknown groups. No,
yeah.
I prefer the known people. Okay? We will see the known people. There are no known people.
So in the...
No.
It's okay.
Okay. Known people. These are the two guys that we know. We have these guys in the training set. This is Abdullah Faisal and Abu Barak al-Baghdadi. Okay. So we can see all the faces, all the images from this guy, and the videos where the images are. Okay, and in the other side we have the unknown groups, but this is here we have all the unknown people that is not classified, and here we have the groups from the whisper classified, for example. This guy, okay, and this we have that this guy is in the same group. We have 1, 2, 3 videos from where this guy is, but we don't know who this guy is. Okay, so the idea is just to classify these guys as a first step to get the identifier. You can use now, for example, an external service from internet or an intelligence services for the police, etc.
With this database, you can see in which other videos this person appears and these kind of things. We don't know who is this person, but we can trace this person across a lot of videos, a lot of images, and this kind of things.
So, okay, we talk about the technology, and the technology has a social impact.
Yeah.
So, right now, supermarkets or retailers are using this kind of technology to monitor the people that are in the supermarkets.
Yes,
okay?
Walmart is trying with this kind of technology to identify the customers.
They are trying to know what is your face when you see a new product, when you see an offer, etc. Okay? Tesla is watching you every time that you cross the street. Okay?
Yeah.
This is a good information that in a moment in the future Tesla sell to other companies. Okay? And even you can buy it in a Snapchat, just showing what you want. Okay? You can show a thing in a Snapchat and then buy the
and offer an Amazon product.
So if you have no time to create this kind of system, you can buy this camera in Amazon, and you obtain a lot of machine learning algorithms and pre-training data set. You have a lot of tools and try to use in your house or in your company. I don't know.
And all of this is boxes in a camera. It's very easy to use.
Beside these company examples, we have the most controversial and my favorite example, that is the China Social Score program. Okay, I don't know if you are familiar with this program, but China is developing a program that's trying to qualificate or to put remember just a score.
Yeah, a score
in each citizen, and the program will be nationwide by 2020. Okay, imagine the place where it's a big brother. It's not that good. So we need to defend. Okay.
Yeah,
this is not good for us.
Yeah.
So the idea is you can spend money and, for example, buy this Justice Cap. Okay, this is just a simple cap that has a LED, an infrared, that blinds the cameras. Okay.
Yeah.
Even you can buy this glasses. It's more cheaper. It's in a Kickstarter project. Okay.
In this case, don't have infrared LEDs. It's working, reflect the infrareds of a camera and blinds the camera. Works better with cameras with night vision, because the night vision of the cameras are only with infrared LEDs. There are the infrared LEDs.
The infrared. Okay. And the cheaper is this. Okay. You can buy some makeup.
Yes. It works very well, because all the makeup
cheat the system.
Cheat the system. Don't identify the nose, don't identify the cheek, and this works very well.
Okay, there are no cameras that identify you, but all the guys remember you.
Yeah, all the people remember you.
And this is our takeaways for you today. The first is open source intelligence must include video processing. Okay, it's an important data source. Okay, we have a great state of the art. We have a lot of tools. We have a lot of technology. And if you are afraid, just you can buy a horse mask.
Like us.
¿Dónde está?
It's dangerous, but it's funny.
We can answer the question with the mask.
Okay.
So that's all, guys. Thank you very much.
Yeah, if you have questions.